Good morning, dear students. In the chapter water, right now we are going to start with physical properties of water. Composition of water you already know. H2O, two atoms of hydrogen combined with one atom of oxygen to form one molecule of water. Water is a pure substance and is a compound. Ratio by number between hydrogen and oxygen atom is 2:1, whereas by weight it is 1:8. How? 2:1 because there are two atoms of hydrogen, one of the oxygen. 1:8 because mass of two atoms of hydrogen is 2 AMU, whereas mass of one atom of oxygen is 16 AMU. So 2:16, that is 1:8. This is ratio by mass, and this is ratio by number of atoms between hydrogen and oxygen in water molecule. Let's come to physical properties of water. Color, odor, taste. First, normal category. Water, pure water is colorless, odorless and tasteless substance. If water tastes to us, the drinking water, potable water, that is because of the dissolved gases and minerals into it. Due to presence of mineral salts, the water gives taste. The pure distilled water is tasteless, colorless and odorless liquid at normal temperature, I mean 20 to 30 degrees Celsius. Otherwise, at lower temperature, it may stay naturally only as ice, and in the air or on heating at boiling point, it converts to its gaseous form, that is steam. Melting point and boiling point of any substance is always same, and so for water. Melting point and freezing point are same, and that is 0 degrees Celsius for water, and so for other pure substances. And boiling point and condensation point are same for water and so for other pure substances, and that is 100 degrees Celsius. The meaning is, at 0 degrees Celsius, if water's heat is taken away, then it converts to ice of 0 degrees Celsius, and if ice of 0 degrees Celsius is given heat, then it melts to become liquid water. So melting point is also 0 degrees Celsius and freezing point is also 0 degrees Celsius. Both the process take place in the same temperature. Difference is that whether heat is being absorbed from water or heat is being provided to the water. If heat is being provided, then solid form will melt to liquid water at 0 degrees Celsius. Same about boiling. Water boils at 100 degrees Celsius to get converted to steam. Steam of 100 degrees Celsius, if heat is taken away, then it will convert back to water of 100 degrees Celsius. Then effect of pressure on boiling and freezing point. Children, when air pressure or any sort of pressure increases, then boiling point of water also increases. It means at higher air pressure, boiling point of water will be more than 100 degrees Celsius. These freezing point, melting point, etc., when we say so much temperature, it is taken at a standard pressure, that is 1 atmospheric pressure. It means pure water's melting and freezing point at 1 atmosphere is 0 degrees Celsius, and pure water's boiling and condensation point are 100 degrees Celsius at the same 1 atmospheric pressure. If pressure increases or decreases, then even for pure water, boiling point and freezing point will be different. At low pressure, boiling point is less. At higher pressure, boiling point is more. And without doing it artificially, even naturally it can be checked. For example, you know that at mountains and hilly areas, there are less layer of air, so there is less air pressure. So there water boils at a temperature lower than 100 degrees Celsius. And if we use pressure cooker, then pressure cooker we do not allow steam to move out. We close the lid with a rubber gasket so that steam doesn't move out, and we put a pressure on the top, so until it goes beyond the air pressure it doesn't open, so steam keeps accumulating inside the pressure cooker, and it reaches, according to quality of pressure cooker, 2 to 3 atmospheric pressure. At that higher atmospheric pressure, boiling point of water may be 130 to 140 degrees Celsius. This is the reason why food get cooked so quickly in pressure cooker, because food get cooked at higher temperature. In hilly areas, the things which take time to get cooked like pulses etc. take too much time. If we do it naturally in an open utensil or a normal utensil covered with lid through which steam keeps passing out, it boils at lower temperature than 100 degrees Celsius. Therefore, food takes more time to get cooked, and that is why it becomes very useful if we use pressure cooker, because pressure cooker has nothing to do with natural air pressure, because artificial air pressure inside the pressure cooker is 2 to 3 atmospheric pressure, because steam is not allowed to escape out. So steam itself creates pressure on the surface of water being heated. So boiling point of water increases and decreases with air pressure. What about freezing point? Freezing point effect is just opposite. Freezing point increases when air pressure is less, and freezing point decreases when pressure is more. When someone skates on ice, then due to weight of the person, the pressure on ice increases, and as a result, at a lower temperature, like maybe they are -2 or -3 degrees Celsius, or maybe -5 or -10 degrees Celsius, despite that ice melts due to high pressure. Once the it moves away, skiing, I am talking about skiing, then what happens? That it refreezes, because melting point of water is 0 degrees Celsius, whereas the atmospheric temperature may be less than 0 degrees Celsius in minus, so ice doesn't melt. But due to high pressure, it may melt. It means boiling point of water increases and decreases with increase and decrease in pressure, whereas freezing point of water decreases when pressure increases and increases when pressure decreases. Okay, then effect of impurities on boiling point and freezing point of water. Obviously the chapter is of water, so we are talking about water only. Effect of pressure on boiling and freezing point is that boiling point of water increases at higher pressure, decreases at lower pressure. Lower means than 1 atmospheric pressure, because 1 atmospheric pressure is the standard pressure at which normally we quote melting point and freezing point and boiling point and condensation point for any pure substance. Normally we write boiling point of water is 100 degrees Celsius. We do not mention pressure, because when we are saying this, it is understood that it is standard boiling point at standard pressure. And what is standard pressure? 1 atmosphere, that is 76 centimeter long column of mercury's pressure. Okay, or we can say 760 millimeter long column of mercury's pressure. So effect of impurities on freezing point we discussed. Now we are going to discuss effect of impurities on boiling point and freezing point of water after discussion of effect of pressure on melting and freezing point. Now let's talk about boiling point first. In presence of impurities, boiling point increases, but in presence of impurities, freezing point decreases. So take it like this, that if we add normal water which is having salts and impurities, gases present to it, its boiling point is a little more than pure water, that is 100 degrees Celsius. And if we add salt to it, then if salt means common salt from outside, then its boiling point increases further. That's why when we put soil in the food being cooked in the starting only, then food get cooked faster in comparison to if after boiling and cooking we add the salt afterward, because impurities increase the boiling point of water, whereas the effect on freezing point is just opposite. If impurities are present in water, then its freezing point decreases. It means if you are freezing normal water in freezer, it may get freeze at 0 degrees Celsius, maybe -1 or -2 degrees Celsius easily. But because pure water, potable water has very little impurities present into it, though it has impurities but not too much. But when we add mix, means cream, milk, sugar, etc. for making ice cream, then the freezer is to be set at much lower temperature, like -10 degrees Celsius or so, because then only it will get freeze, because freezing point decreases when it is not pure water. So the ice cream or kulfi mixture will get freezed at much lower temperature than 0 degrees Celsius, because in presence of impurities, freezing point of water decreases, whereas in presence of impurities, boiling point increases. Okay, let's come to when we talk, we can give example of seawater. Seawater doesn't freeze so easily. At the same atmospheric temperature, pure water or normal potable water or clean fresh water will get freeze, but ocean water won't freeze. It will freeze at a lower temperature because seawater is very impure due to presence of excess of salts dissolved into it. Seawater's freezing point is much lower than 0 degree Celsius. So if the atmospheric temperature is 0 degrees Celsius, then seawater doesn't freeze. Because of impurities, freezing point of seawater is much lower than normal pure water. Okay, then we come to specific heat. So I think specific heat we'll discuss in the next video, and the another physical property, anomalous expansion of water, in the next video. So that's all.